Oh, hello, didn't see you there. My name is Kyle Coberly, and we are here to talk about Auth. So this is a three-parter. We're just going to do the first part today. And here's kind of an overview of what we're going to do. So in part one, what we're doing today, all we're doing is talking about how we make users with hash passwords in a database. That's it. So by the end of the lesson today, I hope that each and every one of you will be able to create new users in Rails and maybe explain a little bit about how hashing works. Looking forward, once you've created these users, we'll need some way to say like, hey, I made an account earlier, I'm that person. So we got to figure out how we verify that somebody is who they say they are. And then once we know who somebody is, we need to be able to use the fact that we know who somebody is to say maybe a little bit about what they are and aren't allowed to do. Cool. So that's our little three-part overview. We're going to do this first part in a couple pieces. First part, you're just going to watch me do this. It's a very straightforward process. There are steps. Then you guys are going to help me do it a second time. And then we're going to do it a third time, except you're going to do it. I do, we do, you do. And then we'll talk a little bit more about hashing. Sound like a plan? Sounds like a plan. Any questions before we get started?
This is Rails, right?
Correct. The principles of this work in anything. So once we get through these three, maybe I'll show you what this thing would look like in Node and Express, but it's the same shit. Good question. What else? Cool. So steps for this, 90% of it is just like making any other resource in Rails. So I want to fire up a fresh project. Don't follow along, just watch me and take notes if you want to. So I'm going to make this, call it Rails new -- API, and we'll call this Auth part 1, take 1. All right, so I fire up a new Rails app. The very first thing that I need to do is install Bcrypt. This is even easier than it may sound, because if we hop into the gem file for this, if I hop into the gem file for this, it's actually already there. There on line 17. It's just commented out. All you have to do is uncomment it. Ta-da! We do that, and then if we do bundle install, like magic, now we have Bcrypt in our app. Step 2, we're going to make a route to create a user. So if I go into the router and I say any post request to users should be routed to the users controllers create method. You could do it that way. You could do it like resource. Is it resource or resource or resources? I always get this mixed up. Resources.
Resource singular?
Is it?
I think it's resource.
No,
Yeah.
it's resources.
I'm 99% sure it's singular.
Okay. Resource users, and then we could say only create. These are the exact same thing. Doesn't matter which one we do. Cool. So I have a route to create a user. Now I need a controller to create a user. So I can Rails G controller users, plural. Cool. And then if I go into that controller that I just made, I can make my action for create. So I could say, I want to take whatever username they give me. I want to take whatever password they give me. And like, you can put anything else you want on this also. If this is like a user account sign up, and they also put in their age or their birthday or their favorite food or whatever. Like, this is just like any other Rails model, or we can make that. So I'm going to save that over here and fire it back. And I'm going to give it a status of created also. Cool. Done. Next, create a user model with a secure password. This is the only part of the entire thing that's different. So I'm going to Rails G model user singular. And I'm going to go to that model that it made. Has secure password. That's it, just like that. It's a macro, the same way as belongs to or has many or whatever else. We don't need to pass anything into it. We just need to put it at the top of the model. Has secure password. That's what that came from Bcrypt, by the way. That gem that we installed in step 0, that gave us this has secure password macro. And then if I go to the migration that made, I'm going to put in the username. Is the other part that's different. Password underscore digest. So in the controller, I called it password. In the database, I'm calling it password digest. Cool. So if I run that migration, I'm done. That's all we need to be able to do by the end of this. Here, I'll prove it. So if I fire up Postman, which seems to be taking longer and longer and longer these days. And there it is. It's especially well because Postman is just a browser. I don't understand why it started taking this long, but whatever. Okay, if I'm running this server on port 3000 and I make a post request to users, and let's say I want, oops, no trailing commas, like admin, best password there is. Oops, I have to actually run the server. I run the server and fire this request off. Hey, what do you know? Made a new user. That part is kind of funny. We'll talk about that in a sec, but that's it. I have created a user in Rails. In step 2, I'll figure out how to like send this password back over and verify that it's me. And then we'll figure out how to use that to make things that you can do on a website and things you can't do on a website unless you're logged in. Pause there. What questions do you have?
May I please see your model again real quick?
Yep.
Cool, thanks.
Other questions?
What's like actually doing that?
making the weird password digest thing?
Yeah, making the actual.
Bcrypt, but we'll talk about that after we get the steps down. Any other questions? All right. So time to blow all this out. It's a brand new world, and y'all are going to help me do it all over again. So Phil, how am I going to get started here?
Did you delete your Rails API or are you still there?
Yep, we're a brand new. I got nothing here.
Cool. So you're gonna do Rails new API.
Okay.
And let's give this like a name.
Yeah. So let's see. It's call it take two. Oops. All right. So that fires off. Chris Fallen, give me the next step.
CD into that folder.
Cool. Then what am I gonna do?
Wasn't that somebody else's job?
No.
You're gonna install Bcrypt.
Yeah. How do I do that?
You're gonna go to your gem file and uncomment it, and then run bundle install.
Beautiful. Thank you much.
You're welcome.
Uncommented. It is bundle installed. Cool. Tara, what am I doing next? Unmute.
Sorry. Are we up to making routes?
Yep.
Great.
What do I do?
I don't actually know the route. I always use that resource generator that makes the model and the controller and the route. So I was interested in how you did it before, but I don't know how.
All right, cool. You're going to give me an answer by the end of this, promise.
Okay.
Roz, help me and Tara out. What are we doing?
Do a post
Where?
in your routes. Sorry, I thought that was a little step.
There we go.
Yeah, so post users in string, comma, 2, colon, string users, hashtag create.
Beautiful. Very nice. So let's break this down just a little bit. If I wrote this out C style, it would look like this. Like the syntax on that is kind of goofy, but ultimately this is all that's happening here. We're invoking a function called post. We're passing in the string of what the little URL fragment should be. And then we're passing in a hash that has a key of 2, and the value is the name of the controller separated by an octothorpe, and then the name of the method that we're going to call on that controller. That's
Wait,
all.
Kyle, what did you say after users?
Octothorpe. That's the actual name of this symbol.
How the fuck do you spell that?
Oh, they didn't have that on Friends?
No, sorry, coding was not really a thing back then.
There you go. Octothorpe.
Thank you.
I think it hasn't. Okay, I got it right. It does have an E at the end. Cool. Questions about this syntax for routes? Okay, now pretend I didn't do it. Tara, help me out. What am I doing here?
Yeah, so we gotta go into the route.
Okay.
And
Now
then
what am I
it
doing?
post quote users,
Good.
comma 2.
Oh, sorry, I did that wrong. Then what?
Users, I didn't write it down, users hashtag create, like, is that right?
Yes, very good. Brava, brava, bravissima. All right, Marnie, give me the next step.
I'm sorry, I had to step away for a second.
So we
Do
just
you-
finished making the route.
Okay,
This doesn't exist yet though. So what do?
so you have to make your create method.
Make my create method inside of what?
Is that under the controller?
Inside of the controller. What controller? I don't have one yet.
Oh, so we'll make a controller.
Yeah. What should it be called?
I would say users.
Yeah. Models are singular, controllers are plural. Always, always, always in Rails. Okay, thank you very much, Marnie. Nate G, give me next step.
So you made your controller. We're gonna make that create method.
Yeah. So what goes inside here?
Def create in at users equal users.create. What is it? Username, params, username,
Yeah.
and then password. Same thing.
Very nice. And then how do I cap this off?
Oh yeah, render JSON.
Yeah. What am I rendering?
Users at users.
And then if we just do this, it gives you a status code 200 back. We're grownups now, though. We know how to use the correct status codes. When we make a new resource, the correct status code to come back is a 201. The way you do that in Rails is say status with the symbol created. And that'll fire back a 201 instead of a 200. Okay, there's very nice. Thank you much. Marissa, there's one thing we got to change on this, though. It's not quite right.
Yeah, that was confusing me. I think it just needs to be singular because
Yeah,
you're just creating one user.
exactly. Models are singular. Always, always, always. Okay, very nice. See, Ben, give me the next step.
We need to set up a password.
So that would be like when we actually make the account. We still got one more kind of compound step that we need to do to set all this up. Got the route, got the controller. What's next?
We don't need to migrate it, do we?
Almost. This doesn't exist though.
Oh, we need to create a user model.
Yeah.
Yeah.
Awesome. So I'm in a Rails G model user singular. Very nice. And then Jamon, help me out. I've only seen your name written. You're muted.
And then you go into your user model.
Yep. What do I do in here?
Is that where you do has user password?
Almost. It's not
You-
this though. It's not user password. It's not has loosey goosey password. It's not has corruptible password. Not has easy to guess password.
Blinking.
Has safe password. That's closer.
Okay, you're at a mall and you're being sketchy. Who do they call?
Secure.
Hey!
There it is.
Very nice.
Nice. Thank you.
Also, how do you say your name?
Jamin.
Damon. There we go. Thank you very much.
Yep.
All right, Blake, help me out. What am I doing next? Blake here? I'm not sure Blake's here. All right, Nick Gray, help me out.
Then you want to migrate?
Yeah, before I migrate, one more thing I got to do before that.
Not sure.
What would I migrate?
I
I have a model, but I haven't really done anything else past that.
have a model. What would you migrate?
I don't migrate models. I migrate what's. Also starts with an M. My 85% of the word is the same. Migrate
I'm blanking.
a migration.
Oh,
So Nick Ray, what do you migrate?
immigration.
Cool. Jamin, what do you migrate?
Migration.
Cool. Ben, what do you migrate?
Migration.
Oh man, we're learning so much today. Okay, Nick, now that I'm in this migration, I got to put 2 lines in here. What are they?
So you just go t.string space colon username and t.string space colon password underscore digest.
You got it. Very nice. Very nice. All right, Will Neal, bring me home, man. What's the last thing I got to do?
Am I on mute again? Let's see, where are we at? Render JSON?
Did that over here.
Okay.
I have all the code that I need now. One last step. Somebody's incorrectly guessed it 3 times so far.
You've made, this is creating your migration. I guess you can go ahead and migrate now? Yeah, sorry, I came in a little late, my bad.
You're fine. So now I can migrate. And that's it. That's the ball game, man. So if I serve that up and I try to make a new user with that, looks like a new user to me. Questions about this process before I make you do it yourself? All right, so I'm going to give you 7 minutes. I'm going to leave the steps up on the whiteboard. These are the steps. I want you to give this a shot. You'll know you did it right if you can send a Postman request to it and get all this, the goofy string back for password digest. If you did that, instead of getting like admin or whatever password you have in there back, you did it right. All right, 7 minutes on the clock. Give it a shot on your own. Go. But this is a real parallel. This changes everything. It bends, so you can get around corners and stuff. All right, we got 2 minutes left. I want to do a quick check-in. Throw up a fist to 5. Fist is I have no idea what we're supposed to be doing right now. 5 is I got a password coming back. Throw it up on the screen. Throw it up, hold it up. Okay, thank you, thank you, thank you.
I'm having issues with my Bcrypt.
Yeah, me too.
Did you bundle install?
I did.
All right. Let's just
Yeah, I uncommented it out in the routes, and then I bundled install, and it's still not.
I'm getting errors when I bundle install.
All right, keep going. Another couple minutes, and then we'll do it again together. All right, cool. One more time. Throw them up, hold them up. How far did you get? Fist to 5. Okay, thank you, Chris. Thank you, Marnie. Thank you, Nate. Thank you, Ben. Thank you, Nick. Thank you, Will. Thank you, Phil. Thank you, Roz. Cool. All right, one more time together, and then we're going to talk about hashing a bit. All right, so I'm going to make one more of these. All right, first step for the bundle, for the Bcrypt. Go into this folder, open up the gem file, uncomment it out, save, bundle install. Questions so far?
I don't want to slow up the train, but that did not work for me. I'm getting tons of errors.
Well, we still got so much more to do. But any questions about that specific part? Cool. So next step, the routes. Oops. Yeah. Go over to the router. You could have done post users to users create. You could have done resource users Solamente. Create. Either one of these is fine. Questions about that step?
I was just missing a comma in one of mine.
Beautiful. Cool. Next up, the controller by Rails G controller users, plural. And pull up that controller and make a create method. Surrate. Come on, man. Friday for everybody. Make a user singular. User.create username params username password, not password digest. Password, it's password in the controller, it's password digest in the database. And then fire that on back. Questions about this step? Cool. So now I need this user model to exist. So I Rails G model user. Open up that file. Has secure password. And then I go to the migration. And I need a username. And I need a password digest. And once I have those things, I do my migration. And we're done. If I serve up the app, and try to make a user, there she blows. All right, Tara, you still having issues?
Yeah, I never got past install Bcrypt. It doesn't, it gives me an error as soon as I run bundle install.
All right, why don't you screen share and let's take a look.
Okay. Okay.
All right, looks fine. In your terminal, hang on, I can't see the bottom of your screen. If you just move the window up just a little bit, I think you'll be all right.
Okay, let me.
Ah, there we go. Cool. So give me a Ruby space dash V. A dash V.
Oh, of course.
Ooh, 266. That shouldn't be a problem. All right, let's try installing it from scratch. So that command they gave you above that says gem install bcrypt -v3116. If you copy just that part, yeah, all of that, and then take off that little tilde or the backtick at the end. But otherwise, you should be able to run that. Yep. Yep. There you go. Fire that off. All right. Scroll up just a touch. Okay. Stop. Now back down. Missing. An active developer path. Oh, do you have Xcode installed by chance?
I don't think so, but it's
You might
possible.
need to, because that installs a whole bunch of other dependencies that I think that's what's not working.
Okay.
Quick show of hands. Raise your hand if you ran into a similar issue as Tara. Anybody else? I think there was one or two of you. All right, Tara, you and me are going to sit down after this and get this one figured out. Cool.
Okay, sounds good.
Awesome. Any other questions about this process?
Could you just put your controller back on the screen for like a hot second? Thank you.
Cool. Other questions? All right, that's objective one. Now we can create new users in Rails. Fair warning, the if and when we get to part 2 of this, the very first thing I'm going to ask you to do is do all of this stuff on your own. So spend some time getting fast at that. We're going to do that at the beginning of all of these. You should be able to just shit it out in a couple minutes. Okay, next, let's talk about hashing. So this goofy thing that came back from the database, that wasn't my password. That's not admin. Can anybody venture a guess as to why the thing that came back wasn't admin? Oh, one more thing. If I look into the database that got made for this, which is in DB, this thing right here. So if I just hop right into that database and select all from users, there we go. I've got this, I don't see admin anywhere in there. I have it as the username, but it's not there as the password. Well,
Is that because it's secure?
it is secure, but how are we going to know it's me? When I log in with admin, how on earth is it going to figure out that I am who I say I am?
Is that because it's encrypted?
Not encrypted. So there's 3 related concepts that you'll hear like the general public use interchangeably, but they're 3 different things. One of them is encoding. Another one is encrypting. And the third one is hashing. 3 different ideas. So what we're doing is hashing, which is not encrypting, but you're on the right track. Any guesses? Let's take one more guess. How we're going to figure out that I am who I say I am, even though me as the user, I have no clue what this is.
I guess you'll
Is
have
this-
to run.
I want to hear from Tara.
Well, there was an algorithm that turned admin into this
Yes.
smush, and now we need to run that same algorithm again and compare it.
Exactly. We had something that turned admin into this smush. And so when I give admin again in the future, we can presumably recreate this exact same smush. Very nice. We're starting to unravel the puzzle a little bit. But okay. So now the next problem that we have is why run the algorithm in the first place? Why not just store it as admin in the database? Let me hear from somebody else.
If somebody got into your database, they could just steal all the unencrypted
Yeah.
things. And
Yeah, that's the big one. If this database gets compromised and I just store that plain text, yowza. Now you have everybody's passwords. What's worse is if you have everybody's passwords and like you don't demand a ransom, you don't tell anybody, you can just quietly be whoever you want. That could go on for years. Whew. That's no good. So, okay, you recovered a whole bunch of hash passwords. Can't we just like get the magic number or whatever, and now we're just one step away from having everybody's passwords?
Does this have to do with salting?
Yes, yes, it does. That's a word that we'll come back to. All right, I'll stop torturing you. So, encoding is Pig Latin. So if we do something like cat, and then we shift all the letters up by one so that it's DBU, that's encoding. Just as easy to go one direction as it is the other. And once you know how the transformation is done, like you can do it either direction pretty effortlessly. This gets used all the time. So for example, when you're typing keys on your keyboard, like your processor doesn't understand A, S, D, F. All it knows is beeps and boops. So instead, we take some key on the keyboard and we go, all right, well, that's 16. And then somewhere in your computer, 16 ends up mapping to A. For example, we take a look at the ASCII table. 16 is actually a character sequence. Capital A is 65. So 65 comes out of your, like, or the beeps and boops that mean 65 come out of your keyboard. Oh, we know that that's A. A 66 comes out of your keyboard. We know that it's B. That's encoding. Questions about encoding? Encryption is a little bit different. Encryption is reversible. So I could turn cat into something like 3B7. And if I have 3B7 and I know a super secret code, I can also go back. So the only difference between encoding and encryption is that going forward or backward is equally easy in encoding. In encryption, it's easy to go one way, it's difficult to go the other way. And the reason why that works is actually a really interesting property of numbers. It has to do with the fact that squaring something is mathematically very simple. Finding the square root of something is mathematically very complicated. So you take some giant fucking prime numbers, you add them together, and then square them. If you knew what one of the original prime numbers was, pretty easy to work the problem backwards. If you don't know what one of the original prime numbers was, impossible to work the problem backwards. That's how encryption works. Hashing is if I take all of these and I do something like add them together. So let's say this is 3, 1, I don't know what T is, 20, something like that. All right, so we take all of those, you turn those into number values, and then we just add them together. So that's 4, 24. And then maybe it has to be one character. And so then we add those. and we get 6. So this is Kyle's shitty hashing algorithm. We smush cat into 6. Also pretty easy to do one direction. But what makes that different than these other two? If I turn cat into 6.
You can't go back because you don't have enough information.
Correct. If I try to reverse that, 6 could have been anything. 6 could have been A 6 times. It could have been BBB. All kinds of different things would generate 6. What you're relying on with hashing is that it's incredibly statistically unlikely that you'll ever be able to intentionally make 2 things that generate the same hash. Because real hashes are big. Real hashes look like this. It is just astronomically unlikely that if I put in admin, if I put in something else that created the same hash, that I would be able to do that on purpose. The stars will burn out of the sky before I come up with another string that I know generates whatever hash admin did. But there are more strings that would also make the same hash. Part of the way that hashing algorithms work is they're not close to admin. It wouldn't be like admin with an S at the end generates the same hash. It might be something that's 400 characters long and is just gibberish that might generate the same hash. We're working with statistical likelihood on that. Another place you see hashes all the time is to identify things. For example, if I look at the, say I make a git commit, these are all the changes in this. If I commit all of those and look at my git history, that is every change that I made hashed together. That's how you can uniquely identify a hash. This commit hash is probably unique, like in the world. Pretty good likelihood that it is, at least. So we can use that as almost like a universal identification mechanism. And so like we've got commits on different branches. We've got branches of branches. We've got all these different commits across a project. Astronomical unlikelihood that any 2 of them will have the same hash. So we can use that to identify them.
What if 2 people were to create the same password? Like you had 2 users, both with ad.
Oh, thank you for that soft pitch. This is where salting comes in. This hash right here, all of this actually isn't the hash. In fact, if I make a whole bunch of other accounts with the same username and password, watch the password digest. Watch what changes, watch what doesn't change. Oops, I gotta run the server. Cool, there's one. There's another one. There's another one. There's another one. This first part doesn't change. That's because this is saying that this was made with version 2A of Bcrypt at a cost of 12. You can, higher costs make the hash even more unlikely that you could intentionally reverse engineer it. They run slower though. And so a cost of 10, the hashing algorithm runs faster. Cost of 20 runs slower, but it's more secure. So we're saying, all right, we're using the Bcrypt algorithm, version 2A of it at a cost of 12. And the other thing that's in this is, I don't know how many characters, I think it's the first 5 or something like that. First couple characters of this are the salt. They are randomly generated by your computer. And then we just tack them onto the end of the password that you send over. So we take admin, we make it admin HVYY5J, and then we run version 2A of the Bcrypt hashing algorithm at a cost of 12, and the result of that is this. So now when somebody else has the same password, it generated a different random salt for that, which means it has a completely different hash.
So you're so you're just giving it admin though, when you sign in, and you know, and you're not like giving it those salt characters. How does it know?
Because this is the thing that's stored in the database. When I go, hey, can you look up the admin user for me? You go, yeah, sure, here you go. That's their username. That's the hash of their password. You go, okay, they gave me admin. If you take the first 6 characters of this part of it and tack them onto the end of admin and run version 2A of Bcrypt with a cost of 12, does it generate this? And it goes, yeah, it does. Awesome. They're who they say they are.
What would happen if you gave it the hash?
Then it would try to hash your hash and end up with a totally different value. So the reason that you salt your hashes, some of you probably picked up on this. Let's say I did crack a database. I got a bunch of hash passwords. Rats. Not a whole lot I can do with a whole bunch of hash passwords. Until I notice that the same hashes show up over and over again. This one shows up this much. This one shows up this much. This one shows up this much. And then there's a long tail on this. A couple of these just show up just a lot. And I've got a long tail of things that never show up at all. What might I infer from that?
Would be what hashing software they're using?
Well, not necessarily. This is unsalted but hashed passwords. Some of them show up super often.
The ones that show up super often are things like password.
Yes. I could probably make a reasonable guess that this follows the list of the most commonly used passwords. It's called a frequency attack. Frequency in like the statistics sense. Stuff that shows up more often there, this is probably the most commonly used passwords. So I really can't get anything out of this long tail. Don't need to. I've got a whole jackpot right here.
And then once you go backwards, you get everything inside, right?
For that user, like you could impersonate that user.
But like you couldn't use that hash to then like reverse engineer the hashing algorithm?
You don't need to. The hashing algorithm is public. Let's see if they actually have the algorithm here. It's the Bcrypt step by step. There you go. Here's how the entire thing works. It's published. There's a principle in cryptography. Here, I'm going to look it up. Cryptography, everything but the cipher secure. It's a quote or a law. Kirchhoff principle. There we go. A crypto system should be secure even if everything about the system except the key is public knowledge. This is like baseline cryptography. You actually want your algorithm to be public because then other crypto researchers can tell you whether or not it's secure, can tell you whether or not they cracked it.
And the key is another word for like salt?
No, the key is, so with your Rails apps, like Rails generated one for you. We'll see this a little bit more tomorrow. You can also make up your own, but one of the ways the hashing works is whatever starting value you have, that's the key. And so then all of the other things that the algorithm does are sensitive to whatever the initial key was. So the important things that you need to know about this: encoding, same way forward, or easy forward, easy backward. Encrypting, easy forward, very difficult backward. Hashing, easy forward, impossible backward. So in step 2, when you're giving your password, we're going to look up the user. We're going to go, all right, I'm going to tack this salt onto the end of the password they give me and run it through my hashing algorithm and see whether or not it also generates the same hash it did the first time. That's how you secure a password. Ask me some questions about hashing.
Is this like, is hashing like the latest and greatest tech and there's going to be new tech one day, or has this been around for a long time?
Oh, this has been around for a very long time. Oh, funny thing, this might help you remember it better. Hashing isn't a math term. Hashing is a breakfast term. It has to do with hash browns. So let's say like you take a potato and you shave off some stuff onto a griddle and you start making some hash browns, and you take another potato and you do the same thing and you start mixing it all together. Sooner or later, you can't tell which part of the hash browns came from which potato. That's hashing. And then salting was like just a play off of that. But no, hashing is a super old concept. Goes back to like the beginning of cryptography. Now, the algorithm that you might use, I highly doubt you'll be using Bcrypt forever. There were other super popular ones before that, such as MD5. And unfortunately, so like you want your algorithms to be public, right? So that other people can figure out if they're not secure. Well, they figured out that they're not secure. So like, oops, stop using MD5. We found a weakness in the algorithm. So you go, all right, everybody get off of MD5. And then that didn't happen because there's still so much fucking MD5 out there. So yeah, Bcrypt is pretty hot right now. Bcrypt is from the 90s, I want to say. Yeah, 99.
I just wanted to throw in at my previous employment working in the data mines. We used hashes for everything all the time. It's a really, really common thing. Like if we want to buy a Facebook ad and target you on the internet, when you go to Facebook, we would take your email address and hash it and then give that to Facebook. So if Facebook didn't already know your email address, then they still don't know it. but if they do, then they could match it. So we use that a lot for matching. And also in params, like we've been sending in your URL ? equals a param. Right now, how we're sending them, people could mess with them, right? Your user could change the params in the URL bar. So we would have hashes of the params so that people couldn't interfere with them. That's just like 2 things. We use them for all kinds of things.
Yep. They're super handy. And even in like the MD5 thing, like you can still use MD5 as IDs. That's fine. You just can't, it's just not secure. So anything that will let you're using it to secure something with a hash, can't use that algorithm. There you go. This is the, that's how you break down that string.
So Kyle, to go back to the, like if you got a hold of a database and then there's that like long tail layout of passwords, if you knew the hashing algorithm and you knew that, you know, those passwords probably match the most common passwords type of thing, couldn't you like back calculate the key and then you'd have all the passwords?
Nope, because
I feel like no is the, like, I feel like I knew no is the answer, but I don't understand why.
Sure. Because if I have 6, I still don't know if it was A or BBB or just the number 6, or like it could be anything. There's so many different things that that could generate this. That doesn't mean that I can reverse engineer another thing going forward into that. And kind of like Tara was just saying, if I already know your email address, I can confirm that something else that I got is that email address, but I can't guess it other than going like A, B, C, all right, A, B. And so like that becomes prohibitively expensive at some point because you're just guessing every possible combination of characters and seeing if you can generate the same hash. Now, you can do that. That's called brute forcing. But what you're trying to do with these algorithms is make that so unlikely. Like brute forcing through a Bcrypt algorithm to get like an average like length password. Well, let's see. How long to brute force a Bcrypted hash? There you go. 4 years of a computer running around the clock with 8 random lowercase letters. You add in uppercase letters to it too. That doesn't make it like 8 years. That makes it exponentially more because there's all those different combinations. You add in numbers, you add in special characters, it flies up.
So I guess if you've got all the passwords with the long tail, like we were saying, right? Like let's say for the sake of argument with the other example, that the most common password is usually cat. So then you've got, you know, the one that appears the most is 6.
Right.
And you know that that is probably cat.
Right. But if you have the salt, now nothing shows up more than once.
Oh, I see what you're saying. Gotcha.
It's unlikely that you'd even have 2 of the same.
Yeah, that makes sense. Yeah. Gotcha. Cool.
So
thank you. This is super interesting.
Sorry, when we were doing like shitty auth in mod 2 for our projects, and you would pass a password back to the user base, like the database, it would show up in the URL as like a param, as a query param.
Yep.
With a hashed password, does that still happen except with now a hash, or does it just like know that it's a hash and won't send anything in the actual URL bar?
So never put that stuff in your URL. And here's why. When you're sending something over the internet, over HTTPS, nobody but you and the recipient can see the body of the request. So this is why you can send your credit card number, your password, any of this kind of stuff. The body of all of that stuff is encrypted. So like I wrote it plain text and then it was encrypted, and my recipient, if they know what the key was that me and the recipient agreed on, they can reverse it back, get whatever they want. But my router can't see it, my ISP can't see it, their ISP can't see it, etc. They have to be able to see the URL though, because they have to know where to send the fucking request to begin with. So like that, your URL isn't encrypted, it can't be. So that includes the query string. So if you have username, password, credit card number, and that stuff's in the URL, like so many problems with that. Not only can everybody in the entire chain see what that is, also it's bookmarkable. Somebody can just like copy paste it and share it with somebody else. Like there's so many problems with that. So when you're doing this for real, you send it in the body of your request instead of the query string.
And you can just do that with like data form.
Yep.
Or form data, sorry.
Oh yeah, absolutely. Like
Cool.
you have to set it up that way on the on your client, but that is how you should do that.
Awesome, thank you.
Other questions about hashing?
And if we go interview for a job and they ask us like, how would you securely store passwords? Is this pretty much the answer? Is there like a level 2 that we should look into?
Hash and salt them is the correct answer. If they go, using what? You should go not MD5, Bcrypt. And there's a 0% chance you'll get asked a more complicated question than that.
Would it be possible to just take you with us to the interviews? Like a phone a friend type of situation.
So there, I actually have a decent write-up of how hashing works. I'll post it in chat. This is like mega extra credit. I don't know this. I wrote it down so I wouldn't have to remember it. But it is really kind of interesting stuff. So if that's doing something for you, that is, this is like a full breakdown of MD5.
Did you write everything that's in here? All of those like
All
stuff?
of them. Yep, this is everything I know about development. This is everything I know about business. This is everything I know about education. I got a little bit on economics and design and a little bit of data, some audio engineering stuff. Yeah, make a GitHub wiki. They rock. And then like when you want to like do something with it, like write or whatever. Let's see. There it is. It's just a Git repo. So it's all on my computer also. Oh, I need to I just finished So Good They Can't Ignore You. Yeah, cool. So I got all my notes there and I can edit something. This book was rad. I can add that and I commit it. And then I can push that up. And now when I go over to this, hey, there it is. Git wikis rock. And now I can like bookmark this and I can send it to somebody. And see, I prefer this to Evernote or Notion or any of the other solutions for this. Cool. Other questions? All right. So I would like everybody to take 3 minutes and write me a DM in Slack explaining how hashing works. It's the interview. And they go, all right, cool. Well, what do you do with passwords? You go, oh, you hash them. How does that work? Brain dump everything you know. Take 3 minutes. Slack it to me. Go. Oop, I'm muted. Tara, I loved your answer. Would you mind reading it out loud?
Yes, if I can figure out how to get out mute. I wrote, hashing is a one-way algorithm that turns strings into a delicious breakfast treat. These tasty hashes are intentionally missing information, so they can't be reconstructed, but we can run other strings through the same algorithm and compare the hashes. The odds of an intentional collision are so astronomical, they're not a practical concern. Salting adds a few characters to keep the hash values unique.
Excellent. Very nice.
How many words a minute can you type? There's no way I could have typed all that in 3 minutes.
Oh man, you should see Marissa's. Marissa, this is an excellent answer as well. Shaman, very good. All right, cool. I feel like we maybe understand hashing a little bit now. Cool. Last questions before we head out for the week.
So there's a part 2 and a part 3 to this?
Yes. I don't know if they'll be like Monday, Tuesday next week, but yeah, probably something kind of like that. But yeah, there's more.
And with Node, is it the same? Is it Bcrypt still, or?
Yep.
Okay.
Yeah, the algorithm is like, so like that gem is the Ruby implementation of the Bcrypt algorithm. Pretty much everybody uses Bcrypt. Awesome. Anything else? All right, all you get the fuck out of here. Tara, hang out. Let's see if we can get your hash or your gem issue figured out. Bye.
Thanks, Kyle.
Thank you, Kyle.